Good morning, friends. We'll start chapter 12, MT level 3, magnetic particle testing equipment, mechanized equipment, semi-automatic equipment, single purpose semi-automatic equipment, fully automatic equipment, portable equipment. Versatile mobile testing units are available in several sizes of ranging from 2000 to 6000 ampere for alternating current. These are all questions maybe. Just check half wave direct current and full wave direct current outputs. Portable magnetic particle testing equipment, direct or alternating current model with infinite current control, lightweight pulse portable operating from outlet, adjustable yoke coil, for magnetizing and or demagnetizing, and assorted accessories, multidirectional equipment. This allows effective inspection of the test object for discontinuities over a range of primary direction as well as beyond that which could be covered with a single magnetization. This is done without demagnetizing the test object or physically moving it between the successive magnetizations. Longitudinal, diagonal, and transverse cracks shown simultaneously. So another system uses two-phase system. AC current taken from same line input 120 degrees apart to the product produce a circular magnetic field that rotates through 360 degrees several times at 50-60 Hz during a magnetic shot 0.5 seconds. This gives almost even sensitivity for discontinuities oriented in all directions. That's shown in figure 2. Main advantage to multidirectional unit is time saving because parts require only one setup and one examination for indications instead of two of each with a conventional machine. Multidirectional unit with bolts and other small parts. Longitudinal fields are produced by field flow device just outside the headstock and tailstock. Flat spiral coil supported between headstock and tailstock and tilted slightly to facilitate run-up liquid suspension. 2.5-inch 64 diameter pipe elbow. From an acid line with internal corrosion erosion grooves that eventually produce a through wall in hole seen as a light spot at the center of bend and resting on a flat spiral coil. Complex parts that defy attempts to calculate magnetizing current using old formulas that have been removed to appendices in ASTM E1444 can be effectively tested. It is rarely possible, even with very simple parts setup, to accomplish true 100% inspection. But the multidirectional technique can greatly simplify the testing of large complex parts to the greatest degree feasible with minimum number of setup. Subsurface indication of internal an engine block position for multidirectional magnetization using toroidal field flow contacts are circular magnetization head shot and longitudinal magnetization coil shot. And dry powder test equipment. Powder selection advantage properties of dry powder are they are more favorable shape and higher permeability in comparison with wet particle. Gray powder. General purpose high contrast powder, the most widely used of dry powders. It is effective in dark surface, whether black, gray, or rust colored. Black powder, specially designed for use on light colored surface. This is clean powder to use as is. It is dust free. It is also most sensitive to dry powder. Black powder, specially designed to use on light colored surface. This is the cleanest powder to use as it is dust free. It is also the most sensitive of dry powders. Its higher sensitivity due to its containing the highest proportion of magnetic material of all the dry powder. Red powder, dark reddish powder is used on light colored surface. Red powder, the reddish powder is used on light colored surface as the black powder. However, since the black powder is just in a silvery or polished surface is sometimes hard to see, the red color may offer better contrast, particularly under incandescent lighting where the red color stands out. Yellow powder. Pale yellow powder features fair sensitivity and good contrast on dark colored surface. Will you please give me 5 minutes, please? The powder should reach the surface of the test object as a thin cloud with practically zero velocity drifting to the surface. So leakage field have only to hold it in place. The usual mistake is to apply too much powder once on the horizontal surface of the test object. Powder has no mobility unless alternating current or half-wave direct current is being used, and a heavy application tends to obscure indication. The test object can be lifted or and tapped. Excess powder falls away and indications are more readily visible. A squeeze bottle is light and easy to use. A powder gun or blower improves application. Wet visible test equipment. The outstanding characteristic of a wet visible particle is that extremely small size. These very fine particles do not act as individual but agglomerate into groups. Particle selection, black powder concentrate, red powder concentrate. Black powder is non-fluorescent wet method. Red powder, same reddish brown oil or water suspendable powder. Suspension characteristics. Water and oils, suspendable concentrates. Water suspendable concentrates cannot be used in oil. These variation additives are insoluble in oil and will not disperse the particles in an oil bath. Oil suspendable, conversely, the addition of to concentrate intended for oil suspension, not soluble in water. However, with suitable water conditioners, some of the oil suspendable concentrate can be used in water. The bath liquid or media may be either a light petroleum distillate of specific properties of water. Of these properties, viscosity is probably the most important from a functional standpoint. So, much lighter distillates have a much lower viscosity than those usually used, but they have other properties undesirable in a magnetic particle bath. Lighter distillate have an initial boiling point lower than the specified and therefore lower flash point, making them a greater fire hazard. For water, there is no hazard. Surface preparation for wet method. Excessive oil on test object surface contaminates the water bath. Paint and plated coatings over 0.005 inch, 0.13 mm thick should be stripped. Tests have shown that non-magnetic coatings of any kind in excess of 0.005 inch, 0.13 mm in thickness seriously interfere with the information of magnetic particle indications of small discontinuities. Wet fluorescent method. Tests are faster and more reliable than with non-fluorescent particles. Bath strength, type of current to be used, current suspension application, lighting condition, bath strength. Bath strength is the major factor in determining the quality of indication. The machine has been off for 30 minutes and 1 hour, 10 minutes agitation is usually adequate. To compensate for evaporation loss, only addition of oil or water is required. compensate for drag out loss, the addition of bath liquid and the particle is required. Bath replenishment for particle determination, the layer of dirt must be carefully excluded from the total volume, and disposal of the bath must conform to all applicable regulations. Suspension preparation. Now add the magnetic particle to obtain a suspension concentration within the following ranges. Visible particle concentration range 1.2 to 2.4 ml per 100 ml. Fluorescent particle concentration range 0.1 to 0.4 ml per 100 ml. So these two they can ask directly. There is plus minus here 0.5, here 0.05. So it is coming on the next stage. But these two, remember 1.2 to 2.4 for visible particle and 0.1 to 0.4 for fluorescent particle testing. Suspension concentration. There is a centrifuge tube. So in the centrifuge tube, you have to measure, and when you measure, it will give you this. So if it is less than 1.2 means it is useless. Same here, less than 0.1 ml for 100 ml, it is useless. It cannot. There should be some optimum. Optimum is here maybe 2.3, here maybe 0.3, something like that. Place 15 ml, 1 heaping tablespoon of fluorescent magnetic particle material in the blender vessel. Add about 100 ml bulk media to the vessel. Operate the blender at high speed for about 10 minutes. Do not overheat the particle. Pour 100 ml of mixture into test centrifuge tube. Place the centrifuge tube in its stand. Place the magnet at the bottom of the centrifuge tube. This is to drag the fine particles out of the bath media and the bottom of the tube. Let the mixture stand for 30 minutes. The magnet in place. After letting it stand, illuminate the tube with ultraviolet radiation. In a darkened area, only the particle layer should infloresce. The fluorescent in the liquid indicates that dye is separating from the magnetic particles. Do not use these magnetic particles for mixing test bath. If no fluorescence is visible in the media, proceed with its use according to manufacturer's instruction. Suspension application. Either by immersion or flooding, then recirculated and reused. Prepared bath is widely available in pressurized aerosol cans for spraying, such as cans, usually contain oil-based baths. Very convenient to use for spot checking, a small area test in the field. Dry powder liquid concentrate. Wet paste concentrate. This transferred to the mixing cup or bowl. Bath of liquid added to a little at a time and mixed until a smooth, thin slurry has been produced. This slurry is then poured into the tank at the point where the agitation system will pick it up and disperse it. Drag out of magnetic particles caused by mechanical and magnetic adherence to the test object, tending to reduce particle concentration in the bath. Drag out of liquid caused by film that adhere to the surface of test object. Water bath safety. Water bath issues: if no rusting can be tolerated, a higher concentration of rust inhibitor may be used. In no rusting can be the use of water bath suspension is not recommended for field testing operations unless facilities exist to test the serviceability of the wetting agent, dispersing agent, rust inhibitors, anti-foam agents, other additives that are required in the water suspension. So here again, fluorescent particle plus minus 0.05 ml per 100 ml recommended range for any selected concentration. Visible particles in plus minus 0.5, that is 1.2 to 2.4. This is 0.1 to 0.4. So laboratory may select 0.3 ml per 100 ml for optimum fluorescent particle and 2 ml is 1.2 to I think 4 ml. Sorry, 1.2 to 2.4 ml. So 2 is good one. Optimum visible particle concentration. This concentration would be maintained within plus minus 0.05 for fluorescent, 0.5 for visible. So there is a settling test centrifuge tube. Settling centrifuge test device is shown in the figure 8. The bath strength for oil bath suspension should be checked daily before use and after every 8 hours of continuous operation. Water suspension should be checked for bath strength and wettability daily before use and after every 4 hours of operation. Water suspension should be checked for bath strength and wettability daily before use and after every 4 hours of operation. Bath strength and wettability. Thoroughly agitate the suspension to ensure particle distribution. Run the suspension through the hand hose and nozzle for at least 1 minute. This ensures suspension in the hose is fresh and agitated. Fill the 100 ml centrifuge tube with agitated suspension using the hand hose. Demagnetize the suspension in tube to reduce clumping. Place the centrifuge tube on the stand and allow it to settle on a vibration-free surface for at least 30 minutes for conditioned water suspension of 60 minutes. Illuminate the suspension in the centrifuge tube with ultraviolet light radiation in a darkened area. Only the particle layers of fluorescence. Fluorescence in the liquid indicates bath breakdown. If the suspension's fluorescence is reduced or eliminated, the cause of fluorescence is fine magnetic particle remaining suspended in the media. If the level of fluorescence remains at the same level, the fluorescent pigmentation is being stripped of the magnetic particles. In this case, the suspension should be replaced. When spray bottles are used, the technician is responsible for mixing the suspension properly and agitating it sufficiently during use. Pressurized cans, on the other hand, are labeled to indicate the particle concentration when filled, but this concentration level may not be maintained from the first use to the last. Pressurized cans must be thoroughly agitated before each use. Fluorescent background check. Obtain a clean glass tube sufficient length to reach from middle of the bulk media container at least 6 inch 150 mm above the container opening where it is vertical position. Insert the tube slowly into the bulk media. Place a thumb over the protruding end of the glass tube and remove the tube from the container. Illuminate the media in the glass tube with ultraviolet radiation in a darkened area. If the media doesn't hint fluorescent, proceed with the use. Fluorescent in the media indicates that it is unsuitable for fluorescent magnetic particle testing. Oil-based media contamination check. Loosen the cap, cover, seal, or plug on the bulk media container. Leave the container undisturbed for at least 1 hour to allow the content to settle. Remove the cap, cover, seal, and plug from the media container. Use clean glass tube and sufficient length to reach from bottom of the bulk media container to at least 6 inch 150 mm above the container opening where the tube is held in the vertical position. Place the thumb over one end of the glass tube. Insert the other end of the glass tube slowly in vertical position into the bulk media. Ensure the tube is all the way to the bottom of the container. Release thumb pressure on the upper end of the glass tube for 5 to 10 seconds, then replace the thumb over the end of the glass tube. Remove the glass tube slowly from the bulk media, maintaining its vertical position. Before removing thumb pressure, observe the level of contamination in the glass tube, water, and other contaminants. If present, should be evidence in the lower portion of the tube. If contaminants are evident in the bottom of the container, siphon off the good media to within 2 seconds 50 mm of the contamination level. Fluorescent test material. The particles for this method are magnetically the same as the visible type, but they must carry the fluorescent dye and binding material that holds the dye and particle together. The coating of the particle would tend to make them less effective in producing indication where it is not perfect that to be easily visible. A fluorescent particle indication requires only a small fraction of particles needed for the non-fluorescent type. Thus, the overall effect is an increase in sensitivity. Maintenance, the separation of fluorescent pigment from the magnetic particle. Noticeable fluorescence of the solution with a reduced fluorescence of the particle signifies separation. The accumulation of magnetic dust or dirt on the bath, which doesn't occur in case of visible particles. The accumulation of fluorescent oils and grease from the surface of tested object. Surface preparation for wet flows and methods. This is the removal of surface oil and grease. Most petroleum distillates, lubricating oils, and grease fluoresce with various degree of brightness. You need surface preparation. Fluorescent bath test variables. Ultraviolet radiation. Generation of ultraviolet radiation in type mercury vapor arc discharge valve. The high pressure component is quartz tube containing mercury and small amount of neon gas. The starting procedure requires 5 to 15 minutes to fully vaporize the mercury and produce full output of ultraviolet radiation. Ultraviolet lamps should be energized for 15 minutes before the test is performed. The ultraviolet lamp should produce minimum light intensity of 1000 microwatt per centimeter square at a 15-inch 380 mm distance from the test object to the surface of filter. Hold and protect the bulb, hold and support the filter, prevent leakage, unwanted visible light and ultraviolet radiations, permit directing the beam on the surface of tested, provide a means of handling the bulb. The filter is a special cobalt glass that filters short wavelength ultraviolet radiation and long wavelength visible light. Carbon arc system, the radiation spans wavelength from 10 to 700 nanometer. However, instead of an inert gas, the tube contains metallic mercury, low pressure fluorescent bulbs. Mercury vaporized and emits ultraviolet radiation with wavelength of about 250 nanometer. 254. This wavelength is not useful for fluorescent testing. Therefore, the inside of the tube is coated with phosphor that is activated by the hard ultraviolet radiation. And emits ultraviolet radiation and visible light in the wavelength range of 320 to 440 nanometer. The amount of useful ultraviolet radiation at 350 nanometer is relatively small. However, large amount of both harmful and short ultraviolet radiation below 350 nanometer and visible light of about 400 nanometer. So below 320, these are hard, and this is problem. This can just burn your eye retina, which is emitted through the phosphor. Visible light. Visible light is because of phosphor. Some of these undesirable wavelengths are often removed by making the tube from cobalt glass. So the filter of cobalt glass filters out this 320 region. High pressure arc bulbs. Different sizes from 2-watt pencil to a 400-watt floodlight. Most frequently used size up to 100-watt bulb. Okay, we'll stop here.